Hello everyone. Today in this video we'll be discussing the previous year questions of UNIX, and we'll be covering module wise, and there are like 10 to 15 questions from each module. So if you like this video, hit the like button and don't forget to subscribe to my channel, and let's get started. In the first module, the first question is explain the UNIX architecture. So what is the architecture of UNIX means how is the UNIX made? Okay. So there are mainly three things which you need to keep in mind. In the core we have hardware. Okay, hardware comes first. Okay, after that to cover the hardware we will be using kernel will be interacting with the hardware, right? So the kernel comes on top of hardware, and finally we have the application part. Okay, three things are there. First hardware, and after that on the top of that the kernel is there, and all the applications run on top of kernel. Okay, so kernel also acts as an interface between the hardware, means the core computer, and the applications which we use, and these are just the commands. Okay, like hardware will be itself, okay, and the kernel will have commands like cpp, cd, shell. So in the second layer you will be just writing what are the commands used. Okay, any of the commands you can write, and after that at the top layer you can write the any application names. Okay, here any application file name, everything you can write. Okay, so that's how you'll make the diagram. The first thing is you have to make the diagram. After making the diagram, what is the next thing? It's common sense, you have to write what is in the diagram, you have to explain those things, isn't it? So you will be starting with the first thing, which is kernel. Okay, so kernel is the core of operating system. It's in the middle part, and it's loaded into the memory when the computer gets started, and it manages the system memory, process, and the priorities, right? 3 to 4 points about each of these. Okay, like kernel is the first, and then comes the shell. What is shell? Shell is nothing but these things. Okay, we'll be accessing the kernel using these commands. So these commands are written in a IDE called as shell. Okay, so that is the shell. It acts as an interface between the kernel and the user cannot directly access the kernel. This kernel, the user cannot directly access the kernel. He has to access using the shell commands. Okay, so that is known as shell. It acts as function command interpreter. It receives and interprets the commands. Okay, that's the second thing. What is the first thing? Kernel. The second thing is shell. After you have defined kernel and shell, then the last thing which I told you, like application part. Okay, here you will have the files and the process. So files and the process are nothing but the data which on which you are going to do the process, and process is the way of doing the task. Okay, and you can write some information about the file, like it's text or binary, and about the process also write one line. After that, system calls are nothing but the inbuilt functions which can be accessed using the programs, and they can be used to call, like whenever we want to do some things and that function is inbuilt, we'll be using the system calls. Okay, so this is basically what you have to write in the first question, explain the UNIX architecture. The second question is explain the features of UNIX. So features of UNIX, mainly there are 7 features. So you can remember it in this way. You have 2 times multi, so it's multi-user. If multi-user is there, obviously multitasking will also be there. So first 2 points you got in your mind. Okay, the next one is about how you can remember is PP, pattern matching and programming facility. Okay, first one is multi, and 2 multi, and 2 starting from P and 2 starting from T. Okay, the building block approach, like it's using the basic shell command to do the bigger tasks. Okay, so if you want to make a big building, at that time what we'll be doing, we'll be putting one brick here, then one brick here, one brick here, like that. So each of these command is nothing but one brick. We'll be using these bricks to perform small tasks, which will be eventually means if you perform for a long time, that small task will join to become a big task, and the big project will be over. Okay, so that is the building block approach. And UNIX toolkit, you have many features in the UNIX, and pattern matching means UNIX gives the means option to search using the patterns, like the grep commands and wildcards using the star and question mark, which we'll be discussing in the upcoming modules. Okay, so that is the feature of UNIX, pattern matching. And programming facility, you can write the shell scripts in it. Documentation, you can save some things in the UNIX, like your files and all. So these are the main features of UNIX. Okay, and with a neat diagram, this is the third question. With a neat diagram, explain the kernel shell relationships in UNIX operating system. So between kernel and shell, what is the relationship that we have to explain? First you have to make the diagram. So whichever question comes first, like in that diagram is required, first you make the diagram, then see in the diagram what all you can find, circle that things and write about each of these things. Okay, so that's how you approach the question in which the diagram is also there. So how to make the diagram is, first make the kernel, like make a rectangle here, right inside that write kernel. Second is write shell, because that's what we have to means explain about, right, the relationship between the shell and the kernel. After you have written the shell and the kernel, shell is accessed by whom and kernel is accessed by whom. Shell is accessed by the users. We access the shell, we access the shell and write the commands, right? So write here users, and they access the shell. Then shell directly does not communicate with the kernel. Shell will use those commands to do the utilities, means utility files are there, it will act on that, and the application programs, it will act on the utilities as well as the application programs. And then what is the result the result that is needed to be fetched from the core memory, that will be accessed by the kernel. Okay, and the kernel contacts with the CPU. So this is the diagram which you have to make, then explain each of these points. Like there are 4 things here, 4 major components: kernel, shell, utilities, and application programs. So these are some of the points which I have mentioned here. About the kernel, it is the process control and resource management, and the shell, it is more visible to the users, it receives and interprets the commands, and it interacts with the system, utilities and applications. What is utility? Like text editor, search programs, sort programs, these are utilities. And application programs means they are inbuilt applications which are present in the Unix system. So those are the applications. Just make the diagram, explain these 4 points. Okay. And the next question is about the internal and external commands. Internal commands are built into the shell, it is inbuilt functions, so they perform the commands like chdir, cd. These are the inbuilt functions, that is known as internal commands. External commands means which are the commands which need a separate file. So in that file, what does that command need? Suppose that there is a command xyz. What does xyz command do? It should calculate the sum of 2 numbers, for instance. So what will happen is there will be a file here, xyz.cp something, and this file will be having the logic to perform the addition of 2 numbers. It will be written in C program or Python how to add 2 numbers, and while you use this command, will be passing the arguments. Since it's to add 2 numbers in this example, we'll be passing the arguments here, and that will get executed, and that is known as external command. This separate file is stored in the memory. Okay, it's not inbuilt. So that's what the external command means, and the example is ls. Okay, means listing the files. And the fifth question is write the syntax and explain the basic command. These are the repeated commands which have been asked many times. So the first one is echo. What is the syntax? Echo hello. So the output will be like hello. Okay. Next one is about the date. So if we like $date, at that time what will happen is Sunday, August 28. This is the time, and this is the time zone, and this is the year. That will get printed. If we like write $cal, it will output the calendar. Okay. And if we like write who will output who was the user at the particular times. Okay. And password, we have to if you want to change the password, we will be using the password command. And firstly we have to enter the password, then enter the new password, and then repeat the new password. Okay, these are the steps to change the password. So these were the most repeated commands. There are many more repeated commands, so you can go through that in the notes. And let's move on to the next one, which is explain the man command with all of the options. Man means manual. Okay, so there is a manual in Unix. Okay, this is the manual which is present in Unix. So in the manual we'll have what command does what, that information will be stored. Okay, so how does that information store is, it's by using a format, it's stored in a standard format. So that format you have to explain. You have to explain what are the section numbers, different kinds of commands stored in different groups in different pages, and what is the basic format of it, that you have to explain. Okay, so the man command, first write what is the man command. It is used to knowing more about the Unix commands and using the Unix online manual pages. Okay, and man is the system's manual viewer. It is used to display the manual pages, scroll up, scroll down, and search for the occurrences of specific text and other useful functions. It's divided into a number of compulsory optional sections. Every command doesn't have all the sections, but the first 3 are compulsory, like name, synopsis, and description. These 3 things will be there. Name presents the online introduction to the command, means what is the command. By the name we can identify what is the command actually. Synopsis shows the syntax used by the command, and description provides a detailed information. After that, these 3 things are the compulsory things: the name, the synopsis, and the description. Okay, after that we have the section numbers, means for different types of functions we'll have different sections, right? In the actual manual also, like our hardware means hard copy of the manual, what will be there will be different pages, different sections for different domain things, right? So these are the different domains, like executable programs comes in the first section, second section has system calls, and so on. Okay, you have to write this table if you can, and after that you have to write what are the commands which is mostly used. What is command is used to display the short manual description. The second command which is used is approx. Okay, so it searches the manual pages for a keyword or regular expression. Each manual has the short description included with it. Okay, so it searches for the keyword or regular expression in the manual. Okay, so let me consider a manual here. So this manual has many sections: section 1, section 2 and section 3. Okay, 1, 2, 3. You had once encountered the word help, okay, in one of the sections, but you don't know where to find it. Okay, so what you will be using is $approx. Okay, $approx, then you will be writing help. So wherever the word help occurs in each of these sections, that will be displayed. So it makes your task very easier to find out where it actually occurred, and from there on you can read about it. Okay, so that's why approx is used. So the question asked about the approx is important. It's in the exam they have asked to write the syntax of approx and with an example. Okay, and what does it do? So go through the notes to get more information about it. Okay, the next one is about the how to become a super user. Explain how to add users to the group, how to delete users from a group, and how to create and delete user groups. Okay, 3 things are there. So how to become a super user is very easy. Any user can acquire the super user status with the su command. Okay, by using su command you can access the you can become the super user if you know the password. Okay, and example, the user gmit becomes a super user in this way. Gmit user will, what he will do, he will type su. At that time the password will be asked to enter. He will enter the password. If it's right, he will become the super user. If you print the current working directory, he will become the super user. His name will be there. Okay, and how to add, what are the things: add user to the group, how to delete user from a group, how to create and delete user groups. Okay, so suppose that there is a user u1. Okay, there is the user u1 and he wants to join the UNIX domain. Okay, this is the UNIX system domain. He wants to join it. Okay, so what he has to do is he has to add himself. Okay, like he has to create a new user ID, and that one he has to assign to himself. After he gets the new user ID and that's assigned to himself, after that he is supposed to be a part of the group. Okay, no one can be a single user in a UNIX. Okay, he has to be a part of a group. So what we should do, first we have to create a group. Okay, G1. After you have created a group, that's the second part. Then you have to access, means connect the user with the group 1 or join the user 1 to the group 1. That's the third task. Okay, so let's see what is the syntax for each of these and how can that be done. So user management: for the creation and maintenance of user accounts, UNIX provides 3 constraints: user add, user modification, user deletion. So adding the user, modifying the user data and deleting the user. These 3 things are there. How to add user to the group? To add user to the group, firstly group has to be made. So how to add a group? By using the group add. Okay, by using the group add you can create a new group and then you can add the user. So you will be using group add G 2015 USP. Okay, in that way the group will be created. After you have created the group, use this syntax: user add u999 g class. Okay, then this one. Okay, this is the syntax of it. So this creates the user ASP with the UID, this one, and the g class, this one. So you can go through it. What does this mean? Like this is the home directory and so on. Okay, so this is the syntax which you have to write and explain each of these terms used here. That's how you add the user to the group. And creating the user USP. So what was the second question? In the second question we have been asked to how to delete the user from the group. Okay, so how to delete the user from the group is by using the user del, I guess. Yeah, user del. Okay, this is the syntax: user del USP. USP is the user del, if you do, it will delete the user. The third one is to how to create and delete the group user groups. Okay, how to create and delete the groups. Creation of group, that's already discussed above in the first question, and group del is used to delete the group. So what we'll do, group del options group, this is the syntax. For example, if I have to delete the groups, this one group, this is another group, whether I have written the syntax for it, no. Okay, so this is the syntax. Just write the syntax, and if you can write the example also. So that's basically it for the deletion of the user groups. Let's move on to the next question, which is give the significance of lsl command. This is a very, very important one. Okay, and what is ls? Ls means list. Okay, and dash l means it will list along with that much more information. Okay, ls will just list the file names, just the file names will be listed, but dash l, if you include 7 things along with that, will be included. like what is the username, what is the file data, what is the last time modified, and many other things are there. So that also comes in the second module. What are the 7 attributes of lsl command? That's also very important question. So for now let's discuss what is ls command. It is used to list all the files in the directory that match the name. Means if you specify any command like what name it should be there, what pattern should match those files, then it will include that, otherwise all the files will be displayed. So this is the syntax ls, and options will be there, and names, or if you have any pattern matching. So options include display. If you use dash a after ls, then it will display all the files. Dash d means it will display only directories. F means it will display the flag name. So you can go to other examples of the options which are given in the notes, and this is what I was talking about. Long listing. Long listing means dash L is used for long listing. So firstly what will be displayed is total how many files are there, 1340. Okay, so these are the 7 fields, field 1, field 2, field 3, field 4, field 5, field 6 and field 7. Field 6 continues from here till here. Okay, so this is about the date time. Let's discuss what are the 7 fields. Okay, very important. The first field is this one. So this I have copied here, and let's discuss what does this include. The first one is the file type. If it is a dash, it means it's a normal file. If it's D, if D is written in place of dash, it will be directory. If L is written, it's the link file. If S is written, that was something was there like symbolic file or something. But these are the 3 main things, dash or D. Okay, these are the 2 only main things, dash and D. Okay, and here you can divide this into 3 parts: user, group, other. User is also known as owner. So what is RWX? RWX means read, write and execute. So whichever file I have, like I have abc.txt. Okay, this is my file which is called as abc.txt. And what does the user have the permissions to do? He has the permissions to read the file, to write on the file, to execute the file. Suppose it's CPP. Okay, so you can execute the file also, and the same way the group. Which group the file belongs to, in that group what all permissions they have to read, write and execute, all they have, or some of them are not there. Like for example in others means the people other than user and the group. So they have the permission, as in this example it's given like read and execute. They don't have the permission to write, only they can read the file and they can execute the file. Okay, so they cannot modify the file because write option is not there. So that was about the first field which specifies these permissions. Okay, permissions of the file is specified in the first field of LSL. Okay, the second field is the number of links. Links means suppose that you have a directory here, a folder here, inside that many files are there. Okay, so each of these files, how many links are there? Inside this there are 4 files, so the link number is 4. In that way, whichever file I am mentioning here, about which file the information is given here, in that file how many files are present, how many file does that directory maintain. So that is the number which is present here, number of links. Okay, that was the second option, what number of links. The third is the owner, then group, and then the size. Okay, yeah, owner and the group. Who is the owner? His name will be written, and which group is there? The group name will be written. After that, size. What is the size of this file? This is the owner name and the group name. This is the file size, and this is the date time. And after that, this is the file name. So the file name is a.out. Okay, so that was the information about a.out. Like that, many lines will be displayed. In each of this line, what is the information? 7 fields will be there. Like that, how many number are there in total? Like this, how many are there? 1340. Okay. So this is what you have to explain in the LSL command and options. And let's go move on to the next one, which is explain the parent-child relationship in Unix. What do you mean by parent-child? Parent-child is a different hierarchy, right? Different levels of hierarchy. So here is a hierarchy. So in this you have to separate it in based on different levels. In the first level there will be the root directory. After that there will be subdirectories, subfolders and files, right? So this is known as subdirectories. These are the inbuilt functions which come when you install the system. When you install the system, these directories come. And after that you have the subfolders. In the subfolders you will have what does the user do. Okay, means the user's file will be stored here. After that comes the files. These are the folders, these are the files, these are the subdirectories, and this is the main directory. So for each of these you have to explain what is the first group contain. That's what I have told you, that only is written here. And how many you can remember those many and explain what does each of these do. Okay, and There was second group also. It was about the second group, which is the folders. So explain about that, what all it has. Like for example, as I told you, that the users work with, whatever the files and the folders users work with, that comes in the second group. And below the second group is just that, like the files included in that. Okay, so if you have to run a game, in that game what will be there, many folders will be there, inside that many files will be there, right? So this, the whole folders present here is what the user is working with. So obviously the files also, which comes in the third layer, those also the user only is working with, right? That comes in the third layer. You need not mention that, just mention what is in the first row and the second row. Okay, next one is about explain the different types of files supported in Unix. So there are two types, there are three types of files, which are ordinary file, directory file, and device file. Ordinary file can be like binary file or the text file, and the data is stored in that. Directory files contains the names of the files, which has the means suppose that this is the directory, what are the files included here, these names will be stored in the directory files. Okay, so there will be a separate file which is known as directory file, df, and these names will be stored here. Okay, and the third one is the device files. Device files has the information about what are the devices connected. For example, if I have like a printer here, this is the printer. Okay, so what is the what is the speed of printer, or what is the number of pages it can handle, what is the time it takes for printing one page, and what is the RAM used in it, and what are the technical things present in that. It has some IDs. Okay, flags are on or off, those things, all the technical information about the device will be included in the file. Okay, that is the device file. So for each device connected to the system, what are the information about that file which is needed, that will be stored in the device files. Okay, the next question is what is the difference between relative and absolute path name. Okay, so relative means whatever is present at the at this point of time, relative to that we are making the changes, and absolute means from scratch. Okay, so for example, if you have like relative means dot and dot dot will be using. Okay, and dot means the current directory, and the dot dot means the parent directory. Suppose that this is the path which we have. Okay, like a/b/c. So if I use like cd then dot dot, then what will happen is relative to where I am, I'll be changed my directory, so I'll be present in B now. So dot dot is the present directory, and cd dot means the present directory. Okay, so relative to where you are, if the change is happening, that is known as relative path name. Okay, so an example is here. Currently your current directory is this one. If you write cd dot dot, you will be moved to the parent directory. That was about the relative path name. And the absolute path name is you will be specifying from the root what is the path you want to go to. Okay, so that's the only difference. And the next one is about the commands, arguments, and options with suitable examples. So what is a command and argument? A command will be written here, and options will be here, and arguments will be here, means which file you are going to perform the operation on, those things will be written. Okay, so that is the command, and the arguments are here. So some of the options are like it begins with a minus sign, and one of the example is -l. So what happens is L means list all attributes of the file note. This is the argument which on which the means the operation is performed upon, and L is the option, which is what we want to do is list the file attributes, list all the file attributes of the particular file. Okay, and file name arguments means we can pass the file name arguments here. We can have multiple file name arguments also. And yeah, that's basically it about the first module. The module 2, which has the topics ls commands, file permission, 3 standard files, shell cycle, wildcard and grep commands, and shell commands. Okay, so each of these topic has some questions which we'll be discussing now. The first question is explain the 7 field output of lsl command. This we had discussed in the previous module also, so we'll be revising now. So in the 7 field output, the first field is about the permissions. Okay, file type permissions. To get a brief overview of what it is, we will have the type of the file here, and the owner, and the group, and the other. Okay, other means other users. RWX means read, write, and execute. The second option is the links. Okay, links means how many files are under it. The third option is the owner, who is the owner of the file, and fourth option is the which of the group it belongs to, and what is the size is the fifth option, and what is the time in which it was last modified, and which is the file we are talking about is stored in the 7th field output. Okay, that was about the lsl command. And what are the different ways of setting the file permission? There are 2 ways, relative and absolute. Okay, relative means we'll be changing the file permissions based on what is currently there. For example, if the file permission is 1 to 3, if you want to like change 1 to, we'll just remove 3. Okay, we'll write remove 3. Okay, like that we'll write. That is relative permission, and we'll be using these symbols here. For whom the permission wants to be removed: user, group, other, or all. Okay, all means all of these. Either you can write means UGO, or you can write A. Okay. The second thing is either you are assigning an operation or removing it, or it's an absolute one. So we'll be not using this one. We'll be using this one and this one only. And the third one is read, write, execute, which of the following permissions you are making the changes. For example, if the xstart is the file name here, u plus x. What does u plus x means? User is getting the permission to execute the file. Okay. And if you want to perform the multiple operations like remove the execute operation from all and add the read operation for group and others, you will be separating that using a comma. Before that you have to write chmod. And absolute permission means we'll be having the octal values 0 to 7. So each of the permissions given here represent the octal values. Okay, for example, if I want to have like read and execute, okay, so what I'll be doing is r and x. So it is 101. 101 means 5. So I'll be just writing here like 5. Okay, like the number will be written. Each number represents for owner, group, and others. Okay, whatever the number is written, based on that what is the permissions that will be assigned to the owner, group, and others. Okay. The next question is regarding explain the three standard files supported by UNIX. So the first one is the standard input, and that's for the taking of the input, and the output, the standard output, and third one is standard errors. So let's discuss each one by one. The standard input file, it's the file representing the input which is connected to the keyboard. Okay, so whatever we enter from the keyboard, that is getting stored in a file known as standard input file. Okay, and whatever we need to output, that is getting stored firstly in a standard output file, and that gets displayed. And standard errors means whatever the error gets displayed in the means the screen, that is first stored in the standard error file, that is getting displayed in the screen. Okay, so the codes are 0 for standard input, 1 for standard output, and 2 for standard error. And these are some of the information about the standard input. You can go through it, and this is the syntax. So if you want to store the input in a sample.txt, we'll be using the redirection symbol, and standard output is also the same, but here we'll be using the right hand operator. And standard error is the file will standard error, for that we'll be using the symbol same as the standard input, but here we'll be using the file 1 and file 2. If file 2 does not exist, that's content is stored in here. Okay, so the numbers are used, means for the first file 1 is used, for the second file 2 is used. So whatever output comes from the file 1, that will be stored in file list, and then it will be stored in the file list. Okay, means file 2's output. Okay, so file 2 does not exist, so what is the output in that? It is the output like cannot access the file 2, no such file or directory. This text is stored in the file list after the content of file 1. Okay, so that gets displayed first, then this gets displayed. Okay, next question is what are the wildcard characters? Explain the shell wildcard characters with example. Okay, wildcard is just for doing the pattern matching. Okay, so here we have the wildcard character star, question mark, ijk, and x to z, and not ijk, not x to z. So let me tell you the differences between each of these. This any of the characters 0 or more times, this is 0 or 1 time, any character, a single character, and these are the characters either I, j, or k, and these are the characters from x to z. These are the characters, all the characters except I, j, and k. These are all the characters except x to z. Okay, so these are the wildcard characters, and one of the example meta character star and question mark, how to use that. ls chap, if you write star here, after chap whatever it comes that gets displayed here. Okay, that gets selected and displayed. Question mark matches a single character 0 or 1, so if you write like chap and question mark, so either chap will be displayed, like only chap can also be displayed, and after chap if there is a single symbol which is stored as a file name or something, then that will be displayed. Okay, so that was about the question mark and star, and the dot is like it will match a single character, and it can be any character. So if you have like dot and we have question mark, so dot exrc, these are the hidden files, so those gets displayed. Okay, the character class, if you have the set of characters from which the output is needed to be displayed, so we'll be using like a group here, so it can be 01, 02, or 04. If those chapters are present, like chap 01, chap 02, and chap 04, those will be displayed. Okay, and the next one is chap x to z. So if any of the letters belonging to the group x to z comes along with the chap, that will be displayed. Okay, like chap x, chap y, and chap z. Negating character displays all those excluding the group which is specified there. Okay, next question, explain the grep commands with all of its options. Grep is used for the searching of pattern. So in the file, if there is some pattern, that will be displayed. For example, there is emp list,
we are searching sales. If wherever sales comes in that file, that will display, means that line gets displayed. Okay, and same thing goes for multiple files as well. And grep with option, these are some of the options like ignore, v doesn't display the lines matching expression, and displays the line numbers along with the line, and so on. Okay, there are many options. You have to write a few of them, like with an example. For example, for ignore case, it will be like this. If you want to search Agarwal without giving the focus to the case sensitivity, so it will be using dash I. It will ignore the case. So all the places where Agarwal has occurred, that will be displayed regardless of the case, means if it's capital or small letters. And the next question is regarding what is a shell. Briefly give the shell interpretive cycle. Okay, basically what is a shell? Shell is a IDE where we will be writing the shell scripts. Okay, and that runs on the top of Unix operating system. Shell interpretive cycle means there is a sequence. What happens when you log onto the Unix machine, you see a prompt. This prompts remain until you log, until you key in something. So whenever we are on the system, there is something like a prompt, and when we enter any key, at that time it will disappear and the file will start running, means the Unix system will start running. Okay, and this command is special. It's with you all the time, means the Unix command until we exit the Unix command stays with all the time with you whenever you log into the system and shut down the system. Okay, so it terminates when you log out. Okay, and this command is known as shell. So shell has many commands, and among those commands, Unix uses one of those commands. Okay, and some more information is there regarding that. So what is the shell interpretive cycle? So basically there are few steps which the shell follows. So basically that's what mentioned here. You can go through it and write it in your own words. Okay, like for example, there will be meta characters, and there will be some links, means the directory path names and all, which will be using in the interpretive cycle. So after those things are mentioned, the commands and all which are being used. After that, the activity is performed is the shell issues the prompt and waits for you to enter a command. So after you enter a command, at that time the shell scans the command and searches for the meta characters, and it expands the meta characters, then passes the command for the execution. After it gets over, it will wait for the completion, and it's normally executed. Okay, that's what happens in the shell interpretive cycle. And the next question is the file permissions are rw dash, r dash x, and r dash dash. This for the user, this for the group, this for the others. Specify the chmod expression required to change the following using both relative and absolute methods. So the first one is you have to change this one into rwx, rwx, rwx. In relative, what I told you, whatever we want to add and remove, will be using plus or minus, and where we want to add, that will be specifying. Like for example, ugo, where we want to add, like for example, in this u is getting x is getting added here, right, in u. So what I'll write, u plus x. So that's what I've written here. Also in o also x is getting added, so I'm doing that in the same time. So I've written uo plus x. And then go plus w, w is getting added in the g and o, so I have written go plus w, and which file name, xstart. So this is the relative method, and the absolute method we have to just change the numbers. So this is 111, 111, 111. So this is 777. I'll be writing chmod 777 file name. Same thing goes for the rest of the questions as well. So you can go through it and practice. Okay. Next one is what is the output of the following. Here what's happening, ls means list the files, and ijk, any number of times ij or k can appear, and doc is here. So I'll have like for example sample outputs ij k with doc, and since it's star, it can be nothing also, so it will just doc. So these are the possible outputs. And for the next one, here we have a to z. We have to select any letter from a to z here, and then question mark, question mark, question mark, question mark. Okay, 3 question mark are there, either 0 or 1 times. And after that, last question mark is like 0 or more times, so I have just written 1 time here. You can write more times also. Next one is about the star and then dot. So we'll have dot here, and star means any number of characters any number of times, and not s, not h, not ending with sh. Okay, so these are the files which are not ending with sh. Those files we are extracting. Okay, and here we have not 0 to 9. The numbers not ending means the whatever we output, that output should not be ending with 0 to 9. Anything else, it can anything other than 0 to 9, it can be, and means at the end it can be written. Okay, so here we have apple, so the last letter is e. Okay. Next is about the exit and exit status commands. What is exit means when the program is over, we want to return from the program to the main home page. At that time we'll be using the exit. Okay, So shell exit commands like exit 0 is used when everything went fine, exit 1 is used when something went wrong. This is normal termination, this is abnormal termination. Okay, it is through the exit commands or function that every command returns an exit status to the caller. Further, a command or function returns the time if it exits true if it exits successfully, else it returns false. Okay, if it fails. So true or false is returned, and this is the parameter which is used to set like if it is 0 or 1 means the execution was successful or not. Okay, in the parameter question mark it will be stored. Okay, so consider two files here, file 1 exists and file 2 does not exist. This exists, this does not exist. So we have echo dollar question mark. So in this case it will output as 0, which is the file 1 exists, and it will output as 1 because file 2 does not exist. So that information will be stored in question mark, the information which is just a single number, which is 1. Okay, next one is about the logical operators for conditional execution. So what are the logical operators? And or. Yeah, these are the logical operators. So what does and do? And means both should be true, then only it will be true. So what it checks is, if this is false it will not check the other one. The reverse is true for or. In or, if this becomes false then only it will check this one. Okay, if it does not become false it will not check this one. So I have given some examples here. In this I have written the same thing. The first one is like and echo means directory in the emp list. If it becomes true, at that time it will be checking this one also. So first it becomes true here, that will be displayed, which all files has directory in it, and then pattern found in the file will be displayed. Okay, in the other case, if you have or here, at that time one of the condition is true, that is sufficient. So if this becomes true, at that time this will not be executed. So what is the output is just the manager line, this is not executed here. Okay, this is not found in the output because one condition is enough to be true, so this gets executed and it moves on to the next command. Okay, and next question is about the if, while, for and case statements. So these are the syntaxes which you want to remember, which you need to remember. Let's get started with the first conditional statement, which is if. So in if, what happens? If the condition is true, then we will execute something. So the syntax is as follows: if the command is successful, then execute command. So this is the compulsory keyword. If is also compulsory keyword. This is what you want to execute, and if it's not true means this condition is not true. At that time write here else, and whatever you write the command here, that will be executed. And here we have to write fi. Okay, and elif, how it works: if, then, elif, then, and else, then after that phi. Okay, an example is as follows. Here we have a is equal to 10, b is equal to 20. If a is equal to b, then echo a is equal to b, elif a gt. What is gt? Gt means greater than b. Then echo is less than b means sorry, it should be a is greater than b. I have written right, so it should be then a is greater than b, and here we'll have else a is less than b. Then the case conditional, this is the syntax. Remember here, pattern 1, then 1 you have to write, then pattern 2, then pattern 3. Then what is the command to be executed, and 2 semicolon you have to write. So one example is as follows. The menu will be displayed here. So it will be like first the number 1 list of files, number 2 process of the user, number 3 today's date, number 4 use of the system, number 5 quit. So enter your option. That option will be stored in choice, and then case choice. Choice will be selected among the given options. Okay, whatever the value I enter, for example, if I enter choice as 3, it will check with 1. If it's true, it will execute this one, else it will go to the next one. Wherever it finds, it will execute that, and it will end the operation. Okay, else if it's any other number than 1 2 3 4 5, it will be output as invalid option. Okay, so next one is the while looping. So it's pretty simple here. You just have to have while here and a condition here. Do you have to write for compulsory, done also you have to write for compulsory. In between that, write what command you want to execute. For is also similar. You'll have for variables in the list. So there is a list here, means a file name. In that variables is there, means each character will be accessed one by one, and whatever you want to do with that data, you'll be doing in that. Okay, finally we'll be writing here done. For example, for file in chap 20, chap 21, and chap 22, do and the dollar file, what is the file name dot back. Okay, so what will happen is echo file copied to file back, done. So what will be the output is that whatever the file we have in the chap 20, chap 21, chap 22, that will be displayed as, like for example here we have abc. So what will be displayed is abc dot bak, then something else dot bak, and something else dot bak, and so on. Okay, so that will be displayed in the result of for loop. Okay, so the last question is explain the 3 ways of using test command. So what is a test command? Test command is used in 3 ways. First, it's used to compare numbers by using the following operators. and the second one is to check for null, we'll be using these operators, equal to, not equal to. And the file test, it will test if the file exists and it's a regular file, readable, writable, executable, if it's a directory, and so on, okay, by using these options. That were the three uses of the test command. And we have here like get, shift, and here commands. So here what we have is the get assigns its argument to the positional parameters. So there is an invisible positional parameter in the Unix operating system. So if you like set these three numbers, it will be automatically set to 1, 2, and 3. So if you output, it will output the in the sequence. So if you want to output like specifically like 1 is what, 2 is what, 3 is what, you can display it in this way. Okay, so 1 will output 989 and 2 will output 878 and 3 will output 779. Shift transfers the contents of the positional parameter to the immediate lower numbered one. So if you have date here, like date is getting displayed here, if you shift it, what will happen is Wednesday will get cut, November will come here, 9 will come here in 2, then 3 and 4 and 5. So what will be the display is like if you shift it and then display 1, 2, 3, 4, 5, it will start from November, Wednesday has been cut off. Okay, here document is used to refer to the same document. If you want to extract the text from the same document you are currently open it. Okay, so we'll be using like mail Sharma, and here we'll have the here document sign and mark. Okay, so that will be getting fetched from the same file. So that's what about the here operator, and that's all about the module 2. Let's move on to the next module, which is module 3. Here we have few topics: APIs, memory, and functions, process, and fork and wait. So these are the main important topics. Let's discuss what are the questions asked under each of these topics. The first question is describe the general Unix file API with syntax and explain the each field in detail. So what are the Unix file APIs? The general Unix file APIs. So tell me, what do you do first? You will be creating a file here and then you will open it. After opening the file, what do you do? Either you write or read, right? After that you have done, you will close the file. So that's what you have to define. Each means for each of these steps you have to define the API. First is the open API. You just have to add the syntax here, like in what mode you are opening: read only, write only, or read write. Next one is the create. So you'll be creating a path name to save the file. So this is the syntax here, and for the read also the same thing. We will be having read and f description. What is the file's description which we will be going to read. And write means if you want to write the text here, so we'll be passing text and the file description. So file description will match which file it actually is, and that the text passed here will be stored in the f description. Then after that after those things are over, we'll be closing the file by using the syntax close int f description, which is the file description. Based on that the file will be closed. Okay, and some more options also include like fcountel, which is used to set the flags, and lseek change the offset, link to create a new link, unlink to delete the existing link. Stat and fstat are used to retrieve the file status in a different way. And that's what about the general file Unix APIs. You just have to write the API syntax and what it means. Okay, and the next one is explain the concept of file and record locking. So what does file and record locking mean? So if there are two persons here who are accessing the same file here, this is user 1 and this is user 2, at that time he is making some difference here, but he has passed on till here, like read all of this and passed on till here. He won't be aware of the change made here, right? He won't be aware of the change made here. So that's why the problems happen. It will be not in a synchronous manner. They both don't have the same data, so those things arise, right? So for that only we'll be using the file and record locking. What does it say is once the process has been accessing a file, none of the process can be able to access the file. Okay, that's what file and record locking. If it's for the file, it's known as file record locking, means file locking, and if it's for the record, which means the group of files together, it's known as record locking. Okay, that's what I have displayed here, and a sample example is also there. Which you can go through it. And that's what about the second question, which is about the file and record locking. The third one is about the mknod and mkfifo. This is a very important one. Mknod API is used to store the device information. Okay, device information is stored in mknod. So this is the syntax here. We'll have the path name and the mode in which the device files support is means kept. And FIFO means it's called the name pipes means first in first out. So here there will be pipes can be used only between the related process when a common ancestor has created a pipe. So pipe can only be used in the parent-child relationship. Other things it cannot be used in between two functions, and those things it cannot happen just between the parent and child relationship. Okay, that was about the FIFO file, and the syntax is mkfifo here, and Yeah, that's basically it about the mknod and mkfifo. Mknod is used to store the device information, mkfifo is used to store the status information and the networking information and so on. So the next question is, what do you mean by a link file? A symbolic link is an indirect pointer to a file, unlike the hard links which are pointed directly to the inode of the file. Okay, so it indirectly points. Okay, that's known as symbolic link file. Symbolic link files are able to link the files across the file systems. They can link the directory files, they can reference the latest version of the file and which they link, and it are typically used to move a file on the entire directory hierarchy to some other location on the system. Okay, and a symbolic link has these following syntax. You can go through it. Explain the 8 ways to terminate the process. Totally there are 8 ways. Among that, 5 ways are normal ways and 3 ways are abnormal ways. The normal ways are return from the main function, calling exit, and here are 2 types in that: returning from the last thread and calling pthread exit. Okay, so the abnormal termination includes calling abort, receipt of a signal, response of the last thread to a cancellation request. Okay, so after you have to explain 1 or 2 lines regarding each of these points mentioned here. Same thing goes for this also, and after that you have done, and then you will be writing how a C program is started and the various ways in which it can terminate. So how is it started is, when the system gets on, it will get started along with the kernel operations, and how it gets exit is in the following ways. There are 6 ways here. The 3 ways from here to here, just the permanent exit, and here is the temporary exit, like a function call. Okay, so here we have the 2 exit handler, and here we have standard input output temp. Okay, so here the functions come and exit here, and that will be called and requested. So that will happen here bidirectionally, it will happen here unidirectionally, and all of this information is managed by the kernel. That's why you have the connection to the kernel as well. And that was about the ways, explain the 8 ways in which the terminate process with a neat diagram. Okay, this question is about the memory layout. What are the different memory allocation techniques? Memory layout is as follows. Firstly, it will have text segment where the code will be there. And the next one is the initialized data segment, means max count is equal to null. Like that, all the variables which are there, that should be initialized. It should have some value. Okay, then uninitialized data segment, here we will have just the data segment here, like int a, which will not have any value as of now, and it will be assigned dynamically. Okay, so that is the uninitialized data segment. And for stack, we will have the automatic variables which are stored along with the reference information, and heap is used for storing the dynamic memory. And this is the diagrammatic representation here. First we will have stack here, then the heap which comes on the top, and here we have initialized data, and text. Okay. The last one is so this one is about the memory allocation. Here we have 3 techniques. malloc, it just allocates the n number of bytes. Calloc allocates the n number of bytes with along each block also, means each block should have 5 bytes. Like that, it will allocate how many bytes how many blocks we want. And realloc allocates the, means it changes the size of the existing memory. And these are the syntaxes, you can go through it. And after that we have the setjump and logjump. Very important question. So what is setjump? If you are in a program here, at that time you want to start the execution from here. After system call, we'll be setting the jump here. Long jump means after all the small means jumps are over, at that time the final code will be there, that is known as siglongjmp. Okay, but this we just need to have the overall idea of what it is. Okay, and the next one is the get r limit and set r limit. And before that, I forgot to tell you, like there are the syntaxes which you need to compulsorily write, and these are the things which you can mention in your own words. And this is stack for long jump, so it will just start from the main. And set jump will have different sets right in the jumps, so that will be stored in the set jump. Okay, and moving on, we have the get r limit and set r limit. Get r limit means get the resource limit, and set r limit means set the resource limit. So suppose that you have bought a new laptop here, and its charge is very less. So you will means if your friend asks the laptop, you will get r limit. Okay, means you will set r limit, means how many resources are to be used to make sure that the battery lasts longer. Okay, so that is a setting of the limit. Get r limit means you are just trying to know how much the limit is set as of now. Okay, so there are 3 rules governing the change of the resources units. A process can change its soft limit. There are 2 limits here, soft limit and hard limit. Soft limit can be changed to a value which must never be increased further. Okay, and the hard limit is like it has to go through a lot of things before it changes to the hard limit. Okay, only a super user process can raise the hard limit. The next one what you have is the fork and vfork. So let's discuss these two first, then these two, and finally these two. So fork and vfork. Fork means what? It's just created by the parent here. This is the parent here, and after that it means it forks, and the child process is created here, so it will have the same copy and the same values. That is known as fork. Okay, means if the thing is to be done parallelly, at that time fork happens. And what is vfork means? In vfork we will be having the process and the parent id, but with different directions. Okay, means the parent will be here, the child will be here. Initially the data will be quite similar, but not all similar. So the parent starts working more on means himself, so that it gets updated with the new programs, and the child also does the same thing parallelly. Okay, but in vfork that does not happen. In vfork what happens, the parent and the child will be here. The parent will be, means initially they will have the same data and all, but after that it will be going in a separate different ways. For fork it is the same ways, in vfork it is a different ways. Okay, so here are some examples. Here we will be changing the value of glob and 88, which will be finally having the glob as 7 and whereas 89. Okay, so what about the wait and wait PID? Wait is the function which is used to just wait. Wait PID is a function which like I think it does not block the child process. So let's discuss what it is. When a process terminates, it either means the child process is not terminated normally. So here the sick child is sent and the parent blocks the child process. Okay, so that's what happens when the child process does not get ended normally. So let's discuss the syntax of each of these. You can go through it, and what are the differences is that wait function can block the caller, but the wait PID has the option to wait. Okay, and wait PID doesn't wait for the child that terminates first. It has number of options that control which process it waits for. Okay, and the interpretation of the PD argument for the multiple depends on its value PID, and PID is equal to 1 means any child process it will send. PID is greater than 0 means it's equal, PID equal, and PID is equal to 0 means group ID is same. PID is less than 1 means waits for any average child. Okay, some of the options which could be used, or the flags which can be used, are W if exited, wait if exited, wait if signaled, wait if stopped, and wait if continued. So the names itself are pretty simple, which you can understand the meaning also. Okay, so wait PID provides 3 functions which aren't provided by the wait function. Wait PID function let us wait for one particular process, whereas the wait function returns the status of every terminated child. Okay, so that's the first difference between wait PID and wait ID. The wait PID provides a non-blocking version of the wait. Okay, non-blocking version, because wait will always block, and the wait PID has an option to stay unblocked also. Okay, and wait PID function provides support for the job control with the W untraced and W continued. Okay, finally the difference between the exit and the exec functions. So the difference between the exit and exec function is that exit is used for exiting, exec is for executing. Here you can find some pattern here. This is execl. Okay, here we have execv, here cle cve, here clp, and here it is cvp. So exec is here, just we have L or V, then we have LEVE, then we have LPVP. So let's discuss what it is. The difference is that the first log take the parameters as arguments, whereas the last two take the file name as the argument. So that's the first difference, which is the means I have not written the arguments here, but that's what the first difference is. The next difference is that the passing argument in the list, L stands for list and V stands for V stands for vector. Okay, the functions execl, execl and execlc and execlp require the command line argument to the new program to be specified as separate arguments. Then then the other 3 functions execv, here we have ve, here we have vp. So we have to build an array of the pointers to the arguments, and the address of this array is the argument to the then the 3 functions. Okay, in that way the 3 functions will be handled in the UNIX. The final difference is that the passing of the environment list to the new program, the 2 functions shows whose name is end with E, allows us to pass a pointer from an array of pointers to the environment of strings. Okay, so this is what the diagram which you have to make. execlp, here we have vp, here we have L, here we have V, and here we have LE, and here we have VE. So these are interconnected with means each other as shown in the diagram. Okay, the fourth question was about the process identifiers. There are few of the process identifiers like the get PID, get PPID, get UID, get EUID, and GID, and get EGID. So what do these things mean that you have to write, and write an example for each of these. Okay. And the next question is about the explain the Unix support for the kernel and the process with a neat diagram. Okay. Kernel and the process. So what are the differences between kernel and the process? Process is the thing which is needed to be acted upon, and kernel is a platform where all the transactions and the queries execution happens. Okay. So a text segment consists of a program test in the machine executable instruction format. The data segment contains both the starting and the global variables and the corresponding data. So a stack segment contains the runtime variables and the return attributes of all the active functions for a process. Also, you have to mention a few points like the Unix kernel has a process table that keeps all the active information. Some of them belongs to the kernel and are called the system process, and every entry in the process table contains pointers to the pointers to the text, data, and the stack segments, and also to the U area of the process. So this is the visual representation. Here we have the process table, and here we have the kernel region table. Two tables are there, and here we have the truth table, and here's something with the information that is needed to be written after every page. So if you have done that, we can ignore this one and move to the text, path, and stack. So it stores the information regarding the text used, the path used, and the stack used. Okay. The next question is regarding explaining the race condition with an example. So what is a race condition? It's when the two processes are trying to access the same thing and the thing's value gets changed simultaneously. Okay. So that is the race condition. So if you want to overcome the race condition, what you'll be doing, before that, this is the example here. If PID is 0, output from the child, else output from the parent. So if there is a race condition, there will be the mixed output like child parent, child parent, child parent. Okay. But if it's not the race condition, it will be like child, 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 then parent, parent, parent. Okay, like that. So how do we achieve this one? For that, we'll be using the wait and tell. Okay, so wait means whichever the function we are calling wait, like parent, it will wait, means the child's vaccination gets over successfully, and after that tell child means if the thing is over what the child want to perform, then the child will be informing all the parents that the process is over. Now any one of the parent can be able to utilize the resources. Okay, so that's what mainly what you have to mention in the race condition, and how to explain the race condition with an example. Okay, so for example, you can take any example and the output should be shown like first it will be intermixing, then it will be correct output. Okay, so that's all what we have in the module 3. Let's now move on to the module 4.
Coming to the module 4 of Unix, we have 4 topics which are most important, like set ID and get ID. Okay, so these two are the first topics, and the second topics are like pipes. Okay, in pipes we have two functions, popen and pclose. Okay, and similar to pipes are FIFOs. Okay, so that comes in the second topic. In the third topic we have there are two more topics at the end. Let's go through it and see. I'm not actually remembering that. So this is popen and pclose, and this is FIFO, and yeah, message queues and semaphore. So this is one thing, and another one comes under process. Okay, so in the process we have process accounting and process times. Okay, so this is all what is there in the module 4. So let's go through it one by one and discuss. Okay, so the first thing is explain set UID and set GID functions, and with an example, and explain the various ways to change user IDs. Basically, why we need to change the user IDs. Okay, we need to change the user IDs so that it becomes accessible. Okay, so if there is a process here and there is a person who is going to access this one, so if the person is eligible to access but the user IDs are not set, okay, means the user IDs are not allowed to access it, so at that time you have to change the user ID so that the person will be able to access it. So that's why we are setting the user ID. The same thing goes for setting the group ID also. Whatever is applicable for user ID, that will be applicable for group ID as well. Okay, so the first thing what you have to mention is in Unix system privilege
privileges are based on user ID and group ID. So if you want to access something, it is totally dependent upon what's your user ID and what's your group ID. Okay, so that's why we have a need to change it. Okay, so to gain access to resources and prevent access to resources, that's why we have to change the user IDs. In the other way also it's true, like if there is a person who is not eligible to access, but it has a user ID, that person has a user ID through which he can access it. Okay, so at that time I have to change the user ID of that person, right? So at that time I'll be using the function set user ID. Okay, so this is the syntax. Basically just you have to remember set UID and set GID GID. Okay, and there are three rules for who can change the user ID. If the process has set UID function set, the real user ID, effective user ID and saved user ID are set to UID. Okay, means if it is super user privileges means the person is the admin. Okay, if the person is admin, he can do whatever he want, right? So there are three things: real user ID, effective user ID and save set user ID, that all can be converted to UID. Okay, means the person is admin, he can convert all of these to the top level. Okay, in the next case the first and the last will only be set, real and the set user ID will be equal to UID. Okay, and the person does not have super privileges. In the first case the person has super privileges, and in the second case he does not have. In case he does not have, but UID equals to real and saved user ID, at that time the middle one also will convert to UID. Okay, and if both are not set, then it will be means e permission is set. Okay, means if both of these conditions are not true, e permission will be set. Okay, so let's revise what are the means the rules. So in the first rule, either the person will be admin or not admin. Okay, and the third case is if both of these cases are not true, means if the person is he might not be admin, but in this case also we have categories, right? Means UID will not be equal to these two. In that case we will go to third case. Okay, if the if the admin is the user, at that time he can set all of these to top level. If he is not the admin, then he should either have these two as the UID, then he can set third also to the UID. If both is not true, the EPERM is set. Okay, that's it. So these are the rules for changing the IDs. Okay, so what was the first question? Explain the set ID and set GID function. That thing you have to mention why it is used with an example. Means you have to mention the syntax and explain the various ways to change the user IDs. So these are the various ways in which you can change the user IDs. Okay, and after that you have to just means write these things. Only a super user process can change the real user ID. Effective user ID is changed by exec function. By e and e you can remember, and saved user ID is like it's saved by default. By name only you can remember. Okay, these 3 points are optional. The above points are compulsory. Okay, so let's move on to the next one. What are pipes? Okay, what are its limitations? Write a program to send the data from parent to the child over a pipe. Okay, so what is basically a pipe? Pipe is the same thing as we all know what is a pipe. It transfers the data from one part to other part. Okay, that's basically a pipe. If I show you in diagram, you have to make this diagram also, and this is a means process. In that process, these are the two openings of the pipe. Okay, data is sent from here and received here. Means this is FD1. FD1 means write. Okay, whatever data I am writing, that will be sent to pipe and it will be processed here, then it will be sent back to the read. Okay, that's it. That's a pipe. Okay, so basically pipes are created only by only between the parent and the child. In that two cases only pipe will be created. So what is pipes? Pipe is just data structure used for transferring the data from one place to another place. Okay, that is a pipe. That answers the first question. What are its limitations? Limitation is that it's half duplex. Half duplex means only it can transfer the data at a time from in this direction, or if this is not there, in this direction. Okay, if this is not there, it will be empty. Okay, so bidirectional it can't do at the same time. That is the first limitation. Second limitation is it's only means it is formed only when there is a common ancestor, means only between parent and child. Okay, if other processes are there, they can't form a pipe. Okay, so that was about the limitations, and let's see how to write a program to send the data from parent to child. Okay, so before writing the program, you have to make this diagram. Okay, this is how the data is transferred. Like fd0 means read. Okay, fd1 means write. Okay, in both cases fd0 means read, fd1 means write. So here what's happening, observe carefully. The child is writing the data here. Okay, child is writing the data and the parent is reading it. Okay, and in the second case parent is writing the data and child is reading it. Okay, that's what's happening here. And there's a possibility that writing from the child to parent or parent to child. In that case you will make a single diagram. Okay, this is this diagram is for both cases, from parent to child and child to parent. Okay, so the program which we are going to write is about parent to child. A parent has written some data and the child will be reading it. Okay, so let's go through the program and see what are the similarities and how can we remember it. Okay, first let's see the outlook of the program. This is the header file which you have to include. After that int main is there. Okay, in int main all the things will be included. Okay, and finally you will have exit 0. Okay, you understood. First we have to have the header file, then the int main, and here at last it will be exit 0. Okay, after making this, in the middle part what is there? In the middle part, see, if you observe carefully, this is the initialization part. This is initialization part, this is the function part, right? This is the initialization part and this is the function part. Now in initialization you only tell me what all should be there. Okay, int n for saving some number. Okay, for that we will come back later. And fd2 means for writing or reading, for saving that data. Okay, for that fd2 is there. PID is for the process ID, and char line means what data you are going to write, you have to write somewhere, right? So for that you need a line. Okay, so those four things. N is the number for storing read or write, which is the process ID, means fourth process, fifth process and all, and where you are going to store the data which you are transferring. For that line is used. After you have initialized these things, you come to the next part here. In the next part, first is if here, then if, else, else if. If is here, this is a separate one, and if, else if, else. Okay, two conditional statements, first one, second one. Okay, this much you understood. We have initialized the data here. After that the conditional statements are here. Okay, now let's see what are the conditional statements. The first one is if pipe of fd is less than 0, it's a pipe error. Whenever the fd's value is less than 0, it will be pipe error. Okay, now one thing we have understood, fd should be always greater than or equal to 0. Okay, next what it says, if PID is equal to fork is less than 0. Whenever it's less than 0, it is an error. Okay, here FD is less than 0, but here PID is less than 0. Okay, so in that case also we have to output error. If both are not this is not true, both are not true, at that time we will come to the final part, which is else part. Okay, here what's happening, here from the parent to the child it's getting transferred. What does parent have to do? Parent has to write the data, isn't it? Parent has to write the data. Okay, this part you can skip. To write the data, what it does is write fd1 hello world. Okay, just skip this part also. Write fd1 hello world. Whatever you have to write, that will be written in fd1. Okay, and after that, if it's not the case, like from parent to child, then child has to read the data, right? How will it read is from fd0 it will read. What it will read? N. Okay, just forget it will read the data. Okay, that's all you have to write. You just forget the first and the last line. This is the main line. Okay, the data is read from fd0 and stored in N. Okay, that's it. Remember a few points, you will be at least able to write the outline of it. If you go to all the means exactly, if you try to remember, the time is not there, so you might not end up even writing the outlook, means the outer part of the program. Okay, so that's how the data is transferred from parent to child. Okay, the next one is explain popen and pclose function with examples. Okay, popen and pclose, those are the functions used in the pipes. Okay, one thing I forgot to mention you, in pipes when you use, right, what happens is if you are using the read operation, the other part should be closed. If you are using the write operation, other part should be closed. Only one part should be open at a time. Okay, so that's one of the things I forgot to tell. and explain open and pclose function with example. Let's understand what are these functions. These functions are used to handle all the work. Okay, means all the work means creating a pipe, forking a child, closing the unused ends, executing a shell to run the command, waiting for the command to terminate. So basically what are the operations that require the pipes, these two functions will handle it. Okay, these two functions have under them sub functions due to which all the small tasks will be handled. Okay, now let's come to the syntax. Okay, how is the syntax is, the first is popen. Okay, popen's syntax we are considering here. String is there and the type is there. Okay, just remember this one. In popen, what is a string which you want to make a pipe for, and the type of it. Okay, the type of string, just remember it in that way. Okay, and the part before it, okay, how you'll remember is string is there and type is there. Before that, const char. Okay, means for all the means whichever syntax are there, first it will be like which is the data type used, it is constant or not, is it a pointer or not. Okay, these three are the possibilities. Here you should remember the main thing. Okay, either write const char, const int and all, and after that you write string here. Okay, and popen is does the fork and exec to execute the cmd string and return standard io file pointer. Okay, popen means what? Opening means what? You are going to perform some operation, right? So you are going to execute some things, and open means you are going to fork it, means the parent process is there, you are going to perform some operation, you will be making the child process also, so that is fork. So popen makes a child process and executes it. Okay, what you are executing, above only you have mentioned cmd string. After you have done that, you will return something. Okay, just forget about this one. After that we have like r means it's connected to the output because we are reading the values, and w means you are inserting values, so it is the input. Okay, and after the popen we have the next one, which is pclose. Okay, what it does is it will close the standard input output stream. Okay, and waits for the command to terminate and returns the termination status of the shell. Okay, so close means we can directly write from our own self, like it means the termination and its ending. Okay, that's it. And what we have here, the popen sends a cmd string. So popen is for reading and writing, so it will send the cmd string from the child to the parent. Okay, if it's writing from the child to parent, and popen receives the standard function. Okay, popen will receive the function and return the values. Okay, so just popen means either from the child to parent it will be there, or from parent to child it will be there. Okay, so that is popen. And popen is called when the process id of the child and the file descriptor. Pclose is called when along with the called with the file pointer as argument. Okay, and if the value is too high or too low, -1 is returned. Okay, these two are the optional points. The main thing is like what is popen and what is pclose. It is used to perform the operations like whatever is performed using pipes, and this is the syntax. You will be sending a string and the type of string, and pclose you will be just closing the pipe. Okay, and popen is used for executing the function after creating a child. Okay, and a read and write for input and output. Pclose is for termination, and in popen it will have from parent to child and child to parent. That is for the standard output and input. Okay, so that's it, what you have to write in the question. Okay, next one is FIFO, and write a need diagram, explain the client server communication using FIFO. Okay, so the client server communication. So see here in FIFO it's just the a modified version of pipes. Okay, FIFO means first in first out, so there will be a queue here. First process which was inserted, that will be the first to be executed. Okay, so that is basically a FIFO, and the same functions are there. Pipes can only be used in case there is a common ancestor. And how to make the FIFO, like by using mkfifo, where you have to make the path name and in the mode. Okay, and once we have once we have used the mkfifo to create a FIFO, we'll be using we'll be opening it using open. Okay, so what's your first step? Write the definition of what is FIFO, first in first out. It's used as pipes only, and just write the definition of FIFO, which is the means it's a modified pipe, and it's using the algorithm of first in first out, and this is the syntax of it, where you have to create and in which mode you have to create. Okay, after the making of FIFO, what you have to do is you have to use open it using open function. So while opening, there are two cases, like it's a normal case or exceptional case. Okay, in normal case, what happens, read only blocks will be there and all the other blocks will be blocked. If it is write only, all the other blocks will be blocked. Okay, so that's the main thing, either read only or write only will happen, both can't happen at the same time. That's for the normal case. In the exceptional case, open for read write only. Okay, means both will be possible. That's for like emergency purpose. Okay, so this is basically how you create a FIFO and open it. And after that, what are the users? Why are we creating FIFO? FIFO are used by shell commands to pass the data from one shell to another. Okay, FIFO are used for just the data transfer. Okay, and FIFO are used to pass the data between clients and servers. So in the same system, the shell passes the data from one pipeline to another pipeline. Also, the means it can be passed between two other systems. Okay, between clients and servers. Now we'll be focusing on how we initialize client server communication using FIFO. Okay, so yeah, that's it. FIFO can be used to send data between a client and server. For that, what happens is a well-known FIFO is created. Okay, in this diagram, if you see, this is the well-known FIFO. Okay, so in FIFO, what happens, there should be a communication between child and means the client and server. So for that, initially this FIFO is created. Okay, so the client will be writing the request to the well-known FIFO and the server will be reading it. Now if the server wants to reply, in case the server wants to reply, what it will do is it will write the replies to the client specific FIFOs, and after that the clients will be reading their replies. Okay, so that was about the client server communication using a FIFO. The next one is about the message queues and semaphores. What is a message queue? By the name itself you can understand it's a queue in which the messages will be there. So it's a linked list of messages identified by a ID, and there are three functions which you need to write: message get, message send and message receive. This is the structure of the message, and this is the message get syntax, message send syntax and message receive syntax. Okay, that's all what I have tried and explained. Semaphore is nothing but a lock. If there's a process P here, is this process accessible by other process or not? Okay, means this is the resource. If this resource is accessible by other process or not, that is given by the semaphore value. Either it will be 0 or 1. Okay, so either of these means it cannot access, and based on that the testing will be done to the process which is trying to access it, and it will be given the access if it's possible, else it will wait. Okay, that's the semaphore, and there are four functions there, which is the sem get value and sem catch value and sem operator value. Okay, and this is the structure of semaphore, and the values will be changed like -1, and if you want to make it deallocation, it will be +1. So -1 + 1 will be 0, so it will get released. And this one is about the process accounting. What does process accounting mean? After the kernel performs each process, that will be accounted in a separate file that is known as process accounting. So the kernel does that using the CPU, and it stores the user ID and group ID of that function. Okay, so this is how it works. Whenever a parent forks a child, that will be stored in the process. That thing has been done. So whenever it happens, it gets stored everywhere. Means everywhere whatever the changes are happening, that will be stored in a separate document. Okay, when it gets executed, that will also be stored. And process time, how much time it takes to perform a process. So there are three types of time: vault time, user time and system time. So this is the structure of the time. Okay, next question is discuss IPC with all its methods. So IPC means inter-process communication. So there are few methods here which we'll be discussing now. So we will not be discussing all, very important ones only we will be discussing. So first is the pipes. Pipes are objects to transfer the data from one end to the other end. Okay, so there are two things here, one for reading and another for writing. FIFO is the named pipe. It is used to transfer the data in the shell commands and to transfer the data between client and server. The third one is the message queues. Message queues already discussed. We will have three functions here, and semaphores also we discussed. That's the same thing which I have written here. Okay. The next one is about the interpreter files. What is the difference between interpreter files and interpreter? The files that begin with this means notation, that is nothing but the interpreter files. Okay, and they have the absolute path names, So how to this is an example program that executes an interpreter file. Remember, if the PID is less than 0, it will be an error. If it's means wait PID is null, then also it will be an error. But if PID is equal to 0, the path will be executed. Okay, and what will be the output is the argument of I values. So in the shell command, when we execute, the argument of I values get stored here. So when we execute the interpreter file, each of these values get printed. Okay. So to wrap up, what is the interpreter and what is the interpreter file? Interpreter is that which interprets the commands. Okay, and the commands are written in the file called interpreter file. Coming to module 5, this is the program which is to transform the normal process into a daemon process. Write the syntax of kill API. Okay, so how to means transfer the process is that first we will be writing here if PID is of fork is less than 0, it's an error. Else if it's not equal to 0, it's exit 0, and it will only work when PID is equal to 0. Okay, and these three are the things which you have to write. Okay, for initialization. And about the kill API, it's a process used to send a signal to the related process to kill an API. Okay, so this is the syntax. The next question is define signal and explain sigaction API demonstrating program. Okay, so what is signal? You only tell me what is signal. It means a notification, right? So it's triggered when the some event happens. That time signals are triggered. It's either generated from a process or by some error. When the error happens, the signals are generated. These are the different types of signals. And what does the process do when the signal can happen? Accept the default action of the signal or ignore the signal or call a user defined function. Okay, and what is the sigaction API? It's used to set up a signal handling method. Okay, so this is the syntax, and here's the structure of the sigaction API, and here's the program. In the program, first you have to write the call me method, and after that you will come to the int main. Okay, in int main you will have two if conditions. In this if condition, it's a p error, and here also at the last you have an if condition, you have an error. And besides that, you'll have these things which are repeated many times in each of the program. First you empty the set, then you add the set, and then two action commands. Okay, and here's the pause and the output. Next one is the explain the daemon characteristics and the coding rules. So the characteristics are very simple, you can go through it, and the coding rules also, like I'll tell you the brief overview. What happens is it exits the parent command, it sets up a new session, and it changes the directory file, means it directory to root, it changes the current working directory, and it performs what is the thing to be performed, and along with that it will delete the unneeded file descriptors. Okay, so that's what happens in the coding rules. And the next one is the very important one, sigset and siglongjmp API. Okay, so what is the setjump and logjump? Suppose that you are in this main int main function, and you have called a program here, here, and here. Okay, so when you come to this program, you will be executing this program, and this is defined here, and for this it is defined here. Okay, so setjump API, what it will do, it will save the command. Okay, it will save the location where it is to be started from, and siglongjump is that it will skip all this and skip to the from where it is saved. Okay, so setjump is for saving, siglongjump is for means skipping the program. Okay, so this is the syntax for setjump and longjump, and for this we will be using the signals to set and save the mask and restore the mask. So means setjump is used to save the mask in the environment variables, and longjump will be restoring that, and it will start the execution from that point. Okay, so that's what the main difference. And coming to the example, first you have to write the call me method, and after that coming to the int main. Here you have two if conditions, just as the previous one. After the two if conditions, you have if else condition, where the error and the execution will happen, and in between that you will have six empty set, add set, and two action commands. Okay, that's the program. And the next one is what is a daemon process, explain with a neat diagram. Error logging facility for a daemon process. See, daemon are the process which will be running in the background, and it will terminate when the system is shut down. Okay, so daemon does not have the means the permission to write directly on the terminal. So what it does is, whenever the error happens, it has to do something. So there are three ways of handling that error. The first one is the user will send to the this path, and this path will send to the system log. Okay, second is from the TCP IP network, it will send to the UDP port, and that will send to the system log. The third way is the kernel routine, it will directly log to the path here, and the path will send to the system log. So in this way the daemon process handles the errors. Okay, so that's what I've mentioned here, the three ways. And this is an example, you have to mention this example as well. And the next one is mention the different sources of signals. Write a program to set up a signal handles for sigint and sigalarm API. What are the sources of signals? As already discussed, it are generated from an events when some error happens or a parent child process means they do not synchronize properly or they fork. At that time the signals are generated, and coming to signal handler, here you will have the initialization part, and you have the if else condition here. If it's true, it will not, means if this is true, it will be an error. If it's not true, then this will be executed. So here I have written like initialization part here, then here getting the current signal mask, and setting the signal API and the deleting one, and if this thing is true, it will be an error, and those conditions you have to mention. Okay, for the sig alarm API, first you will be writing the call me function, and you will be initializing the things here, and after that as in every program you will be writing the action commands here. After that you have the if condition, and after this if conditions, totally you had two if conditions, right? So this one of the if condition, and this is second if condition. Okay, so whichever is true, based on that will be executed. Okay. The next one is the what is signal mask. Signal mask is nothing but, suppose that this is the parent process, and these are the flags of the parent process, some are off and some are on. So what the signal mask do is, it will inherit the same mask to the means the same things to the child also, but one thing will not be inherited, which is the pending signals. Okay, except the pending signals, all the other things will be inherited. Okay, so see here, but any pending signals for the parent process are not passed on. Okay, and you have to write the syntax and explain each of these things used here. Okay, it's nothing very easy, it's just like empty mask, add, set, delete, set, and set mask and block, and so on. Okay.